Hey there, folks. My name is Jared Ross, and I'm a Senior Product Manager in Azure Networking, focusing on hybrid connectivity solutions. Today, we're going to talk about designing high-performance networks for your hybrid workloads. To set some of the context, we look at some of the types of services that Azure has to offer today. IaaS, or Infrastructure as a Service, Platform as a Service, or PaaS, and SaaS, Software as a Service. And as we set this context, we look at all of the various mechanisms that we connect into these services. Whether or not we're connecting from a branch, where we may want to access our SaaS services over the internet, but our IaaS services over a VPN, for example. In addition to that, we can access these over point-to-site or user VPN services. And those user VPN services run on Windows and Mac OS, as well as Linux, iOS, and Android as well. And then we finally have our headquarters or data center connectivity solutions. And those are going to typically use private connectivity services like ExpressRoute, which allows for a high availability and private mechanism to connect to these services. And this is going to support both IaaS and PaaS for connecting to workloads that are both within your virtual network, as well as resources like Azure Storage or Azure SQL that may be behind Private Link, for example. The first thing we'll take a look at is ExpressRoute, which is a private cloud connectivity offering. In ExpressRoute today, we allow for you to connect to our global backbone utilizing either service providers or a direct connectivity model. We have both access to Microsoft peering, which includes Office 365, Dynamics 365, and Azure public services like Azure Storage and SQL, like I mentioned before. We also support Azure Private Peering, which is an extension of your on-premises network into your virtual network, where you can bring your own private IP space and access your virtual machines from on-premises. Your virtual machines can also access your on-premises network. This also supports Private Link for scenarios where we want to expose an Azure Storage account or Azure SQL, for example, utilizing a private endpoint within your virtual network. The connectivity methods that we have for ExpressRoute today include the service provider model, which can either be an existing co-location or point-to-point circuit where you're present and provide a layer 2 offering, as well as an any-to-any or IPVPN connection, which would typically be a layer 3 provider where you may already have an existing MPLS service, etc., and want to extend your network into Microsoft's network to bring your own IP addresses for your virtual networks, etc. We also have an ExpressRoute Direct offering, which is offered at 100 gigabits per second or 10 gigabits per second. And this is highly available by default to allow customers to be able to directly connect to Microsoft's network, bypassing any other entities in between. Some of the design patterns for ExpressRoute have evolved over time to be optimized for connectivity, optimized for reliability, and optimized for scale. We see some of these paradigms used with our customers throughout the world today. One being the one flat VNet, which is quick and easy to deploy. It has subscription and other limits that may be applied, but there's fewer choices for security and compliance, and it can be very, very simple to deploy. In addition to that, we also can connect all of our VNets onto the ExpressRoute circuit. And so if you have different types of workloads for different business units, or you have different types of workloads for different applications, each of these can be connected to the ExpressRoute circuit to allow for on-premises access for backend services or for on-prem connectivity. And then finally, we have the hub and spoke model, which utilizes VNet peering and gateway transit, where I have a gateway deployed into my hub VNet, and then I peer that VNet with many spoke VNets to allow for centralized management within that hub, while allowing each of my spokes to still have access to on-premises and for on-premises to also have access to them. There is a management overhead with this, and there's bottlenecks in the hub, as well as no native transit between each of the spoke VNets. From a designing for high availability, we want to look at connecting to multiple regions, but also connecting to multiple peering locations. And so with ExpressRoute, we have dozens and dozens of peering locations across the world strategically placed in user markets so that you can connect your global backbone into our global backbone, or your network from your headquarters or data centers into our network. And so some of the mechanisms we utilize to connect these from ExpressRoute circuits to the region include connecting multiple circuits to multiple different virtual networks. And as you can see here, I can connect up to 16 circuits across peering locations for high availability. This was previously increased from 4 circuits. And so if you're utilizing a standard SKU gateway, you'll still be able to connect 4. But with high performance and ultra performance, as well as the AZ SKUs, you'll be able to connect up to 8 and 16 SKUs circuits respectively. From a high availability perspective as well, you'll want to use connection weights or AS path prepending to select the inbound path, and to select the outbound path from your network, you'll want to use local preference. In addition, it's incredibly important to ensure symmetrical routing, especially if you're utilizing stateful firewalls. And so you can use our network or your network to be able to carry this traffic, but you always want to make sure that your traffic that leaves one location enters and exits via the same, as well as when it leaves our network, it enters and exits accordingly. We also have some upcoming features that will make large-scale networks even more scalable with the use of IPv6. Azure Virtual Networks today support IPv6 natively within the platform in a dual stack method. We're also extending this to the on-premises connectivity solutions as well, where we now will also support an on-premises network exchanging routes that are IPv6 to the Azure Virtual Network and having full end-to-end IPv6 experience from on-premises to Azure. The private peering support will support your own IP ranges, and we will not designate which ranges you can use within your virtual network. Today, this requires ER Gateway AZ 1 through 3, but in the future, we'll also support the standard high and ultra performance SKUs. And this will be available in all availability zone regions in 2020. In addition, after much customer asks, we've also included new ExpressRoute Gateway metrics, including packets per second and CPU. This allows for self-service monitoring of your gateway per instance for very fine-grained reporting. This also has native alerting via Azure Monitor and has direct integration into the platform so that you can set up your own alertings and integrate into your ITSM, etc. Next, we'll talk about VPN, which is an internet-based secure connectivity method. The first thing, touching on ExpressRoute, is our recent announcement on VPN over ExpressRoute Private Peering. What this allows us to do is connect to a VPN endpoint and securely, over an IPsec tunnel, connect to your virtual network utilizing your ExpressRoute Private Peering. And so this enables IP secure connectivity from your customer's virtual network to your on-premises over ExpressRoute Private Peering. And so if you have an existing ExpressRoute investment, but you need to make sure that your extra sensitive content is encrypted, we now support this natively within our platform. And this also supports transit from internet site to site and point to site to your on-premises over the VPN tunnel. The configuration is really simple, and you just enable the private IP address on the VPN gateway, you enable using local Azure IP address, and you get going. From a routing perspective, you need to filter to prefer the VPN route for your Azure VNets. And so there's going to be some fine-grained routing that we'll touch on in our documentation. In addition to that, on-premises must advertise more specific prefixes or disjointed prefixes via the VPN connection to ensure that we utilize the VPN connection on our egress back to your on-premises. We do still support single tunnel throughput of about 1 gigabit per second, but you can set up multiple private IPsec connections for greater throughput. From a feature perspective, we're also adding new capabilities to the site-to-site offering. One of them being the FQDN, or fully qualified domain names site-to-site VPN, which supports customers that may not have static public IP addresses. And you can target this site-to-site with FQDN. In addition, we also will support the BGP with the PIPA addresses. And what this will allow you to do is have integrations with other cloud providers on the 169.254/24 range. And then finally, we also have additional custom IPsec policies, and we're adding this portal support as well as custom DPD timeout. On the point-to-site or the user VPN option, we've got a bunch of new portal functionality as well as new capabilities. Point-to-site session management revocation, as you can see in the portal below, now lets me see each one of the users that are connected to my point-to-site and be able to revoke those sessions. We also support on-prem access through ExpressRoute using VPN over ExpressRoute Private Peering. So not only does that support site-to-site, it will also support point-to-site. And then some additional radius and VPN client changes for both macOS, Azure AD, and cert-based authentication coexisting on the same gateway. And to bring all of this together, as we've talked about ExpressRoute and VPN and user VPN, is our Azure Virtual WAN, which provides ubiquitous connectivity, routing, and security in a unified framework, so that I can bring together all of my different connectivity offerings, both for on-premises and within the virtual network, into a model that's is superior for optimal connectivity, resource protection utilizing our Azure Firewall suite, and monitoring across utilizing Azure Monitor and Azure Monitor for Networks. Finally, we'll take a look at internet connectivity. As many of you know, internet connectivity is one of the forefronts that Microsoft focuses on, including connectivity for some of the most core and fundamental services on the internet, including Office 365, Bing, LinkedIn, Azure DevOps, and Azure, of course. The first offering we'll look at is Azure Peering Services. And what Azure Peering Service does is it allows us to be able to optimize the internet connectivity from my on-premises into Microsoft with guarantee of one hop between my network and the hop between your service provider and Microsoft. And this is an enterprise-grade internet connectivity to Microsoft. And so we've worked with many connectivity providers across the world in a partnership so that we have not only local peering redundancy, but also geo-peering redundancy. So in the case that a local metro were to fail, we ensure and we require that our partners have redundancy in these metros. In addition to that, they're high-capacity peers, both with ISPs and exchanges, and it's optimized for internet traffic, known as cold potato. We also have telemetry platforms built into this, which we'll touch on, as well as our industry-leading route anomaly detection and remediation platform, known as Radar. And this monitors 20 million routes across the internet and protects against BGP leaks, hijacks, and withdrawals. Some of the features, as I mentioned, is that this allows for BGP route anomaly detections. So if there's a hijack or a leak on the internet to your prefixes, we'll notify you of that. In addition to that, we'll provide you with performance insights, including latency, and then a looking glass for providers for BGP, for RPKI validations, as well as Trusted Anchor, AS Path, Next Hop, etc. We'll also look at routing preference, which is a new offering that Microsoft has to be able to provide egress options for your services. And so when you're thinking about Azure Storage or Azure VMs, for example, you may not require high optimized network that the Microsoft backbone provides. And so what this does is that this will route over the public internet as close as possible to our internet service providers instead of routing Microsoft's global backbone, which is the default experience. And so on the Microsoft global network, traffic is accepted closest to the user and traverses our backbone until it gets to that resource. The return route also follows our path and exits the Microsoft network closest to the user. With the ISP or internet approach, the traffic is traversed onto our public internet and enters into our closest hosted service region. The return traffic, however, exits Microsoft in the same hosted service region and takes the public internet route to there. And so if we take a look at the actual configuration of this, we create a public IP address and we now select the routing choice that we're interested in utilizing. And so in this case, I want to make my public IP address an internet public IP address rather than a routing preference on my Microsoft network. And now I can associate this to my VMs, my VM scale sets, App Gateway, Azure Firewall, and more. Additionally, I can also do this on my storage service. And so if I have scenarios that are large egress intensive scenarios, think CDN or streaming, I may want to be able to optimize on the cost as well. And this is a really good cost optimized scenario for this. And so I configure my routing options for my storage account, as you can see, either Microsoft network routing or internet routing. In this case, I've selected internet routing. And now I have additional internet endpoints that are created. And again, the default is Microsoft network, but you can see below my internet endpoints now get created with a new -internet routing. And what that does is that favors the internet routing path over the Microsoft network. And that about wraps up in a nutshell everything we wanted to talk today about designing high-performance networks for your hybrid workloads. Definitely check out our website on our Azure Global Network to learn more about all of the Azure networking offerings, as well as to dive into all of the global networking capabilities that Microsoft has to offer. Thanks for watching.